All right, let's dive in. Today we're tackling one of the most famous thought experiments in physics.
Oh, yeah.
Schrödinger's cat. I'm sure you've heard of it, Ron.
Right?
A cat, a box, and a 50-50 chance of things going very, very wrong.
Right.
But the really crazy part is that until we look inside, the cat is supposed to be both alive and dead at the same time.
Yeah, it's like the universe just can't make up its mind. It really gets at that kind of central mystery in quantum mechanics.
Yeah.
How can something be in multiple states at once until we actually measure it?
Exactly. And this new research that we're going to dive into today, it might actually have an answer for that.
Yeah.
And it involves this wild idea called a many worlds interpretation.
Oh, yeah.
Okay, before you list anybody here,
Yeah.
let's break this down a little bit.
Yeah.
We're dealing with quantum superposition here. The idea that at the subatomic level, particles can exist in multiple states at the same time.
Right.
It's like they're flipping a coin, but never actually landing on heads or tails.
Yeah. Yeah, and then the problem of measurement comes in when we try to look at these superposed particles.
Right.
They suddenly seem to choose a state, like heads or tails, when we observe them.
Yeah.
Schrödinger, he used that cat analogy to kind of blow this up to a scale that we can, at least try to wrap our heads around.
Right, right.
The cat's connected to a quantum event, and because of that, it becomes part of this superposition, both alive and dead, until we open the box.
Yeah.
And we force the universe to choose one outcome.
Right. So it's not that our observation, creates the outcome, right?
Right, yeah.
It's more like by interacting with the system, we're kind of forcing it to pick a side, right? A live cat or dead cat.
Exactly.
And what this research is suggesting is that it's not just us doing the measuring.
Right.
It's like everything around the cat, too.
Exactly, yeah. This is where that many worlds interpretation comes in.
Oh, boy.
You might have to hold on your hats for this one, folks, because it gets kind of trippy. The idea is that every single possible quantum outcome actually occurs just in different branches of reality.
Whoa.
Yeah. So there's a universe out there where the cat is totally fine, just chilling, maybe eating some tuna.
Right.
And then another, well, a less fortunate one.
So you're telling me there's a universe where I actually won the lottery?
Yeah, maybe.
I call dibs on that reality.
All right.
But seriously, how did scientists actually test this many worlds idea? I mean, it seems kind of hard to get, data from a parallel universe.
Yeah, it's not like we can just hop between universes and compare notes.
Yeah.
For this research, they use numerical simulations, basically really powerful computer models, to look at how particles behave in really complex quantum environments.
So like simulating a virtual cat in a virtual box with virtual poison and a whole bunch of virtual air molecules bouncing around.
Pretty much, yeah. What they found is that when you factor in all those interactions, even something as small as an air molecule bumping into the box, it acts like a tiny little measurement.
Okay.
And with trillions and trillions of those interactions happening all the time, the odds of seeing that cat in some blurry, both dead and alive state become basically impossible.
So it's not that the cat isn't in a superposition. It's just that the universe is kind of constantly measuring it because of all these interactions and forcing it into one outcome or the other.
Exactly.
But it's happening so fast that we don't even notice.
Yeah.
It's kind of like, if you flip a coin a million times a second, you'd never see it hanging in midair.
Right.
Even though it's technically in both states for just a tiny fraction of a second.
Yeah, that's a great analogy.
Yeah.
The number of interactions just collapses those probabilities so fast that for all practical purposes, the cat's either alive or dead, and we just see that final result.
I see.
And that might be why we see a definite classical world, even though it's built on this fuzzy quantum foundation.
So the reason my coffee cup doesn't suddenly teleport across the room or, dissolve into a wave of probability is because it's constantly being measured by all those air molecules, light particles, and everything else around it.
Exactly.
That's both reassuring and kind of disappointing.
Yeah.
I was kind of hoping for some teleportation superpowers.
Well, maybe someday.
Yeah.
But for now, the takeaway is that the quantum world's full of these strange possibilities, but the complexity of our macroscopic world makes those superpositions really hard to maintain.
Okay. Yeah, that's starting to make sense.
Yeah.
But hold on, before we go around saying that this is like the definitive answer to Schrödinger's cat, you mentioned there were some limitations to this research, right?
Absolutely, yeah.
Yeah.
One big one is that it assumes all those parallel universes, all those branches of reality, are playing by the same rules as ours. And that's a big if. It's also worth noting that this research doesn't really take into account general relativity, like gravity's role in all of this.
Okay, so we're still missing some pieces of the puzzle.
Yeah.
Which isn't really that surprising, I guess, when you think about it, right?
Yeah.
I mean, we're dealing with the fundamental nature of reality here.
Exactly.
It's not exactly like baking a cake.
Definitely not.
But that's what makes it so exciting, right? We're constantly pushing the boundaries of knowledge.
Yeah.
And even if this research doesn't have all the answers, it's giving us, like, new paths to explore.
Exactly. Yeah. It's like opening a door to a whole new set of questions.
That's what we love about science, right?
Yeah.
The more we learn, the more we realize how much more there is to discover.
Absolutely.
And this research, even though it's still very theoretical, it's giving us this glimpse into a future where the seemingly impossible might actually be possible. It's a future where we might be able to use the power of the quantum world to solve problems that today just seem impossible.
Exactly. It's a really exciting time to be studying quantum mechanics, that's for sure.
Now you're talking.
Yeah.
Let's explore those ideas further.
Yeah,
After, well, we don't really have a break, do we?
We do not.
So let's just jump right in and unpack even more of this quantum weirdness.
Sounds good.
And if you're enjoying this deep dive, be sure to like, subscribe, and hit that notification bell so you don't miss out on future episodes.
Yes, please do.
We've got a lot more mind-bending physics to explore.
We do.
So stick around.
Yeah.
So before we were talking about how the universe might be constantly measuring itself.
Yeah.
Collapsing all those quantum possibilities into, the reality that we experience.
Yeah, it's like there's this constant cosmic balancing act going on, keeping things from getting too strange.
Makes you wonder, though, if all these other outcomes are happening in other universes. Right. Could we ever, peek into them? I wouldn't mind seeing the version of me that's like a rock star astronaut.
Well, that's where things get really speculative, right? I mean, the many worlds interpretation is still just that, an interpretation.
Right.
It's a way to make sense of the math.
Okay.
But we're a long way from proving it, let alone traveling between universes.
Okay, fair enough.
Yeah.
Back to, this reality.
Right.
The reality is we haven't even talked about why anyone outside of theoretical physics should even care about any of this.
Yeah, that's a good point.
I mean, I love a good mind-bending concept as much as the next person, but does any of this actually affect our day-to-day lives?
That's a great question, and it kind of gets to the heart of why science is so fascinating in the first place.
Yeah.
It's not just about understanding the universe out there, it's about understanding our place in it.
Right.
We're made of the same stuff as stars, governed by the same quantum rules. So, figuring out how the universe works at its most fundamental level, it's like figuring out the instruction manual for reality itself.
Whoa, so we're all just like walking, talking quantum experiments?
In a way.
That's both awesome and kind of terrifying.
I know, right?
But okay, on a more practical level, are there any, real-world applications for this kind of research?
Mm-hmm.
Or is it all just theoretical for now?
It's mostly theoretical at this point, but that's often where the most groundbreaking technologies come from.
Okay.
I mean, remember, the laser was once just a theoretical concept.
Right.
And now it's in everything, from CD players to, eye surgery.
Right.
So this research, it could be pointing us towards entirely new ways of thinking about technology.
Okay, now you've got my attention. What kind of technology are we talking about here?
Yeah.
Are we going to be building quantum computers that can solve problems in seconds that would take our current computers, millions of years? Are we going to be teleporting ourselves across the galaxy? Tell me we're going to be teleporting across the galaxy.
Hold on, slow down. We're not quite there yet.
Okay.
But one area where this research could have a huge impact is in quantum computing.
Oh.
Imagine being able to actually control and manipulate those superpositions.
Right.
The very thing that makes Schrödinger's cat both alive and dead at the same time.
So instead of bits that are either 0 or 1, we'd have these qubits.
Right.
That could be both at the same time.
Right.
And that would somehow give us, like, insane processing power.
Yeah, it's complicated, but the basic idea is that quantum computers could perform calculations that are basically impossible for our classical computers.
Right.
It's like comparing a bicycle to a spaceship.
Okay.
They both get you places, but the spaceship can take you much farther, much faster.
Okay, I'm starting to see the potential here.
Yeah.
But What kind of problems could these quantum computers actually solve? Like, give me some real-world examples.
Okay, well, think about drug discovery, for example. It takes years and billions of dollars to develop new drugs right now because we have to test millions of potential molecules.
Right.
A quantum computer, it could analyze all those molecules at the same time, which would dramatically speed up the process. Or imagine being able to design new materials with very specific properties, like lighter, stronger, more conductive. Quantum computers could help us do that, which could lead to breakthroughs in everything from energy production to transportation.
So we're talking about potentially solving some of the world's biggest challenges, like curing diseases, combating climate change.
Exactly.
Maybe even finding solutions to problems we haven't even thought of yet.
Yeah, the possibilities are pretty incredible.
That's pretty incredible.
It is. But with any powerful technology, there are always risks and ethical considerations.
Right.
We need to be careful about how we develop and use quantum computing, making sure it benefits humanity as a whole.
Yeah, that's a really crucial point.
It is.
It's like with any powerful tool, it can be used for good or for bad. We need to be mindful of the consequences.
Absolutely.
But for now, let's focus on the positive potential, This research on Schrödinger's cat, while it's still very theoretical, is giving us a glimpse into a future where the seemingly impossible might become possible.
Yeah.
It's a future where we might be able to harness the power of the quantum world to solve problems that seem insurmountable today.
It really is an exciting time to be alive. And witnessing this scientific revelation unfold,
Yeah.
who knows what incredible discoveries and technological breakthroughs are just around the corner. But one thing's for sure, the journey is just beginning.
Absolutely. And we're glad you're joining us for the ride here on the Deep Dive. So stick around. We're going to wrap up our exploration of Schrödinger's cat and what this new research means for our understanding of, well, reality itself.
Yeah.
We've been on quite a journey today, haven't we? Exploring the mysteries of Schrödinger's cat and this new research.
Yeah.
That might actually explain why we don't see quantum weirdness,
Yeah.
in our everyday lives.
Yeah. It really makes you look at the world a little differently.
It does. It does.
Yeah.
Like, is my coffee cup actually a blur of quantum possibilities until I look at it?
Mm-hmm.
Are there infinite versions of me out there living out every possible choice I could have made?
Yeah, it's enough to make your head spin.
It really is.
Yeah, and while the many worlds interpretation is still very speculative,
Right.
it really is a testament to the power of human imagination and our drive to understand the universe.
Yeah.
Even the really bizarre parts of it.
It also highlights how science is constantly evolving.
Oh, absolutely.
What we think we know today
Right.
could be completely overturned tomorrow by a new discovery or just like a different way of looking at things.
Absolutely. Yeah, and that's what makes it so exciting.
Yeah.
This research on Schrödinger's cat, even with all its limitations, is really pushing the boundaries of what we understand
Yeah.
and opening up these new avenues of exploration.
Speaking of exploration, I got to ask.
Yeah.
If we could somehow manipulate these environmental interactions,
Right.
like this research suggests might be possible, what could we actually do with that knowledge?
Yeah.
I mean, are we talking about like controlling quantum outcomes?
Yeah.
Like bending reality to our will?
That's a question that's going to keep physicists and philosophers busy for a long time.
Yeah.
I mean, it's one thing to understand how the universe works,
Right.
but it's something else entirely to be able to control it.
Yeah. I can't help but think of all those sci-fi stories where people can manipulate reality.
Right.
It's both exhilarating and a little terrifying.
It is. It is. But for now, let's just appreciate how far we've come in understanding the quantum world.
Okay.
We've come a long way from a thought experiment about a cat in a box
Yeah.
to these really sophisticated computer simulations that are actually shedding light on the fundamental nature of reality.
Well said. We've covered a lot of ground today, haven't we?
have.
From quantum superposition and the measurement problem to that mind-bending many worlds interpretation and the potential of quantum computing.
Yeah, it's been a wild ride.
I hope our listeners are as fascinated by all this as we are.
Me too. And if this deep dive has sparked your curiosity, I definitely encourage you to explore further. There's tons of resources out there.
Yeah.
Books, articles, videos, all sorts of stuff.
Absolutely. And hey, while you're at it, why not hit that like button and subscribe to our channel for more of these mind-bending explorations of the universe?
Yes, please.
We've got so many more fascinating topics coming up.
We do.
From the origins of the universe to the search for extraterrestrial life, we're on a mission to make science accessible and fun for everyone.
Absolutely.
So join us as we kind of unravel the mysteries of the cosmos together.
Could be an adventure.
It will be.
Yeah.
And before we sign off, I want to leave you with one final thought-provoking question to ponder, okay? If, like this research suggests, the universe is constantly measuring itself, collapsing all those quantum possibilities into the reality that we experience, does that mean that we actually have a role to play in shaping reality? Are we, in some small way, co-creators of the universe? It's a question that might not have, a definitive answer,
right?
But it's certainly worth thinking about.
Absolutely. That's the beauty of science, right? It's not always about finding all the answers. It's about asking the right questions, embracing what we don't know, and just always being curious about the world around us.
Well said. Until next time, keep exploring, keep questioning, and keep that curiosity burning bright. Thanks for joining us on The Deep Dive.